What if I told you that you could unlock some of the most fundamental shapes in the universe just by folding a simple piece of paper? It sounds kind of wild, right? Well, let's dive into this really surprising connection between origami and the secret language of math. So, just look at this. This absolutely elegant curve, it wasn't drawn with a compass or spit out by some computer program. No, it was created from nothing more than a square of paper and a whole bunch of simple folds. See, each individual crease is just a straight line, but when you put them all together, they reveal something totally new. And that really brings us to the big question here. How on earth can an activity as simple as folding paper reveal these deep, profound mathematical shapes? We're talking about curves that describe everything from the orbits of planets to the shape of a satellite dish. Well, the answer is pretty cool. It's that folding makes geometry, well, it makes it tangible. You can actually feel it. So instead of staring at formulas in a textbook, you're literally creating a geometric object with your own hands. The curve isn't drawn first. It just sort of appears from all those straight line folds. Okay, so let's start our little journey with the first and probably the most familiar of these amazing curves, the parabola. The whole process is wonderfully simple. You just start with a line on your paper. In math terms, we're going to call that the directrix. Then you mark a single point somewhere else on the paper. That's our focus, or F. Now for the fun part. Just pick any point on that line and then fold the paper so that point lands exactly on top of your focus point. Make a nice sharp crease, unfold it, and then do it all over again with a new point on the line. And here is where the magic happens. As you keep doing this over and over, all those individual straight creases, they start to outline this beautiful, smooth curve. A perfect parabola just emerges, seemingly out of nowhere. So what's actually happening here, mathematically speaking? Well, each crease you make is basically a line of perfect balance. It represents all the points that are the exact same distance from your focus point, F, and from the point you chose on the line. And that beautiful curve that all our creases are tracing, that is the textbook definition of a parabola, the set of all points that are an equal distance from a fixed point and a fixed line. All right, so we've got the parabola down. Now, this is where things get really interesting. We're going to make just one tiny change to our rules, but it's going to unlock two completely new and totally different curves. So what if we just get rid of that straight line, our directrix, and we replace it with a circle? We'll still have our focus point, F, and we're still going to be folding points from the edge onto it. So how does that one little change affect what we get? Okay, here are the two new scenarios. On the left, you see our focus point F is inside the circle, and on the right, it's outside the circle. That's it. That is the only difference between these two setups. And check out this incredible result. When the focus is inside the circle, all our folds create this beautiful closed loop, an ellipse. But when we move that same focus point just outside the circle, the curve literally breaks open into two separate branches, and it forms a hyperbola. Two totally different shapes, all because of that one little change. I know this all feels a little bit like a magic trick, right? A curve just appearing out of a bunch of straight lines. So let's pull back the curtain for a second and look at the mathematical secret that's making this all happen. The key idea here is something called an envelope. So think of it like this. An envelope is a curve that's formed by just barely touching or being tangent to a whole family of straight lines. Our creases, they're the family of lines. And the parabola, the ellipse, the hyperbola, that's the beautiful envelope they create. And this table really pulls it all together. It all started with the parabola, right? We were folding a line to a point, which is all about equal distances. Then we just swapped that line for a circle. With our focus inside the circle, we got an ellipse. And by moving that focus outside the circle, boom, we revealed the hyperbola. Each one is a totally unique shape, born from such a simple fold. So what does this all mean? Let's zoom out of it and bring this all back to the bigger picture and why it matters. I just love this quote from the source material. It just perfectly captures the whole idea. The final shape, it isn't just a pretty curve. It's a physical record. It's a visual story of the geometric relationship that you built, one single fold at a time. And really, this is the ultimate takeaway here. Math isn't just a bunch of abstract equations. It's this fundamental pattern that's woven into the fabric of everything. You can find it in the arc of a baseball, the orbit of a planet, and yeah, even hiding inside a simple folded piece of paper. And this all leaves us with a pretty fascinating final thought. If these deep, profound curves can be revealed with just a few simple folds, what other mathematical secrets are out there, hiding in plain sight, just waiting for a curious mind and maybe a piece of paper to bring them out into the light?